Hello everyone, welcome to my channel Mechanical Zone. In this video, we will solve numericals related to YouTube manometer. The numericals deals with gauge pressure and vacuum pressure. The first one deals with gauge pressure and second one deals with the vacuum pressure. So in the first, what is the first question? Let us read it out. The right limb of a YouTube manometer containing mercury is open to atmosphere while the left limb is connected to the pipe in which a fluid of specific gravity of 0.9 is flowing. The center of the pipe is 12 centimeter below the level of the mercury in the right limb. Find the pressure in the pipe if the difference of the mercury level in the two limbs is 20 centimeter. So let us draw the figure. The basis of what data is given from here, you can easily calculate the pressure inside pipe. Drawing using graphic tablet is not that good. Hope with that. Trying my level best to draw it proper way. So the pipe where fluid containing specific gravity of 0.9, the gravity of the fluid 0.9. So always remember, manometer there are two types of fluid. One is a heavier fluid and other one is a lighter fluid. One is a heavier fluid, other one is a lighter fluid. Heavier fluid is generally is the mercury, the lighter fluid, whichever that is flowing through the pipe. So try to take the density of mercury as 13.6 into 10 to the power 3 kg per meter cube. As mercury is given, I am telling that thing. Try to take the density of the mercury as 13.6 into 10 to the power 3 kg per meter cube. So these are the two types of liquid which are there inside the. This is the U2 manometer. This is the pipe to which U2 manometer is connected in order to calculate the pressure. The pressure inside the pipe is, let us consider it as P. This is the left limb. This is the left limb. This is the right limb. The shaded portion contains mercury, while as the dotted portion contains the light liquid. So let us consider the first thing that is given. Center of the pipe is 12 centimeters below the level of the mercury in the right limb. That means this distance is 12 centimeter. And what else is given? Difference between the mercury level in the two limbs is 20 centimeter. This distance is 20 centimeter. So what about this distance? This distance is 8 centimeters, obviously. So let us calculate. Just write down what data is given. The data are specific gravity of the liquid flowing through the pipe is 0.9. I am taking the data of light liquid as 1 and heavy liquid as 2. Heavy liquid is here mercury. Specific gravity is 0.9. So the density of that liquid will be 0.9 to 10 to the power 3. Power 3 is the density of water. So this is the formula in order to calculate of water, density of liquid. After that, what else is given? Got the density. Then the height of the liquid in the left limb is equals to 8 centimeter. Convert that into meter. 0.08. Yes. After that, let us come to heavy liquid. In case of heavy liquid, the height is 20 centimeter. that is 0.2 meter, and density of heavy liquid. Heavy liquid is our mercury. So the mercury is equals to 15.6 in power 3 kg per meter cube. This we have written all the data. So let us calculate the pressure. So pressure in left limb of the U-tube manometer will be P plus P, the pressure inside the pipe, and the pressure due to this height of the liquid. So we will always calculate pressure related to this datum. So pressure is equals to P rho 1 G H1. So P, which we need to calculate, rho 1 is our 0.08, 9.81, 0. So I have interchanged rho 1 with H1 and H1 with rho 1. So check that out. Pressure in the right limb equals to only the pressure due to the heavy liquid, that is rho 2 G2. Rho 2 is 13.6 to 10 to the power 3 G.81 to H2 is 0.2. So under the conditions of equilibrium, the pressure inside the left limb is equals to pressure inside the right limb. So I can say P plus 0.08 into 9.81 to 0.9 into 10 to the power 3 will be equals to 13.6 to power 3 to 9.81 to 0.2. So bring this part to this side and minus that thing. So P will be equals to 13.6 into 10 to the power 3 to 9.81 to 0.2 minus 0.08 to 9.81 to 0.9 to the power 3. So multiply this, after that subtract this from this, you will get the value of P in terms of Newton per meter square. So with this you will by this you can calculate the pressure inside the pipe. This is the positive pressure or gauge pressure is given. After this we will go to the next problem where the system contains, or where the pipe contains vacuum pressure. So let us read the question. A simple U-tube manometer containing mercury is connected to the pipe in which the fluid of specific gravity 0.8 having vacuum pressure is flowing. The other end of the manometer is open to the atmosphere. So what is the value of specific gravity of the fluid? 0.8. See, vacuum pressure is flowing. Other end is open to atmosphere. Find the vacuum pressure in the pipe if the difference in the mercury level of two limbs is 40 cm and the height of the fluid in the left from the center of the pipe is 15 cm below. So let us draw from the data what is given. This is the pipe in which the liquid is flowing. This is the U2 manometer. Again, the mercury is given is our heavy liquid. So mercury is given means the density of mercury is 13.6 to 10 to the power 3. So that will be the density of mercury. Take the reference where is I'm taking at AA, the pipe inside which the pressure of P is flowing, which we need to calculate. The given things are here. The mercury level in the two limbs is 40 centimeter. As it is a vacuum, everything you will get in the left limb. Only in the right limb the pressure, which is equals to your atmospheric pressure. This is 40 centimeter, and the center distance from the level of the height of the fluid in the left from the center of the pipe is 15 centimeter. So you can see this is the 15 centimeter part. Here you have light liquid. So what are the data given? The data are specific gravity, the fluid. Again I am telling the same thing, taking the light liquid as first fluid. So specific gravity, right? Specific gravity of the fluid is 0.8. So that density of the light fluid is equal to 0.8 to specific gravity into density of water. So 0.8 into density of water is 10 to the power 3, which is equals to 800 kg per meter cube. What the density of that light liquid is flowing with a vacuum pressure of P. The other end is open to atmosphere. Find the vacuum pressure inside the pipe. The difference between two levels of mercury is 40 centimeter. Mercury level in two limbs is 40 centimeter, and height of the fluid in the left from the center of the pipe is 15 centimeter below. That means H1 is given as 15 centimeter. So H1 is 15 centimeter. Convert that into meter, 0.15 meter. Then the density of the heavier fluid, the mercury, is 13.6 into power 3 kg per meter cube. Try to mention the unit always. Is our 40 centimeter. So what is the value of 40 centimeter in meter? 0.4. So again we will calculate two things. This is the left limb, this is the right limb. Pressure in left limb. What is the pressure inside the left limb? First, the vacuum pressure inside the pipe plus the pressure due to light liquid, that is rho 1, then plus the pressure due to heavy liquid, 2 P H2. So what is the pressure in right limb? So above the atom surface or reference line there is nothing. That means pressure in the right limb is 0. So from this, under equilibrium, pressure in the left limb will be equals to pressure in the right limb. So P plus rho 1 G H1 plus rho 2 G H2 equals to 0. So P is minus rho 1 G H1 minus rho 2 G H2. So minus rho 1 is 800 G 9.81, one is 0.15 minus 13.6, that is rho 2 10 to the power 3 G 9.81, it's 0.4. So from this can easily calculate the value of P in Newton per meter square. As it is vacuum pressure, the pressure will come in negative. So from this you will get the vacuum pressure of the liquid flowing inside the pipe. So you from the above two problems can easily solve for simple U2 manometers, that whether your fluid is flowing with gauge pressure or a fluid is flowing with vacuum pressure. You can easily calculate the thing. But this video I have not done the calculation, but you do the calculation by your own, which hopefully can solve the videos. You can solve the numericals that is shown in the videos or same type of numerical. Thank you very much. Thank you everyone.